Today, we're going to spend a lot of time prepping for a science investigation. That's a timed event. We're going to look at time and mass. Time and mass, the x and the y coordinate on a graph. We're going to look at how things change physical states of matter from a solid to a liquid. You know, there's gases and solids and liquid, and water is the perfect matter to study because water can be water vapor as a gas, it can be liquid water that fills any container, or it can be a solid piece of ice that is below a certain temperature and has length, width, and different dimensions. But today, we're going to investigate how things change from a solid, cold ice to liquid. And we're going to measure that over time. And we're going to see if we can find a way for an ice cube to slow down its melting. So what we're going to try to do is keep the cold in and the hot out. What we're going to be talking about is how heat moves through objects or transfers. So how heat moves, and we can talk about an ice cube that is a certain temperature and it's solid, and then it starts to melt, and so you start getting this melted cube with some water, and eventually you just get a puddle of water. Now, so we have starting with ice, a solid, and ending with water, a liquid. And so we're going to have time. We're going to look at now the time it takes to do this. And we're going to find ways to slow it down. Slow time down. So that's the goal. And we're going to use a scale to actually measure these, a balance scale to measure these. But in our houses, like right now, it's cold and there's snow. And so right now, our houses, we hope, are hot, and out here is cold. And so that's in the winter. And in the summer, that same house in the summer, we want it to be cold, and it's hot outside. So in the summer, we have the sun coming down, and in the winter, we have snowflakes coming down and cold and clouds. Before we work on the hypothesis and the question, let's set up our test. And so on page 163, I'm going to draw 3 bags just like this, okay? And I'm going to call this bag A, B, and C, all right? Bag A, B, and C. A is going to be wrapped in wool. B is going to be wrapped in newspaper. And C is going to be unwrapped. Okay? They're the same size, same shape. I'm going to put an ice cube in each one. Same size, same shape. So go ahead and draw an ice cube in each one. Okay? This one is going to be covered in wool, so I'm going to draw wool around this one. Wool is what a sheep is covered in, so that's our wool. This is newspaper. So there's my newspaper. And this one is just left unwrapped plastic. Go ahead and draw this, and I want to add one more thing. I want you to take your room temperature right now, the room temp. And when you write that down, please write it in degrees Fahrenheit so your teacher or someone can use your thermometer and write the room temperature. My room temperature is 72 degrees Fahrenheit. So go ahead and write your room temperature and make your drawing like this. as you're drawing this picture, I also want you to spend the next 5 minutes or so in your groups to create your 3 bags. Let me just show you my 3 bags. Here's bag A, covered in wool on the outside, so I can still open up my bag. Here's bag B, covered in newspaper on the outside, and here's bag C, unwrapped and uncovered. So the 3 bags, use your masking tape and your materials to make bag A, the wool, bag B, newspaper, and bag C, unwrapped. We also have to set up our balance scale because we're going to measure when an ice cube melts. Every 10 minutes we're going to pour water off to see how much has melted. So we're going to use a balance scale that looks like this, a balance scale. So what we'll end up doing is putting 1 bag on one of the trays, and we're going to use our centimeter cubes, our known masses, on the other side. And so the balance scale, we want to make sure that we avoid what's called instrument error or human error. So if you watch, you can be practicing this, finding the mass of other objects, like finding the mass of your ink pen. Set it on the tray, and then 1, 2, 3, 4, 5, 6, 7, 8. 8 grams. Now, in order to avoid human error, you want to do it the same way each time. And instrument error, you want to make sure that your instrument, for example, take a look here. So this pen is 8 grams. Now I put the pen the same way each time. If I move the pen like this, it's going to affect how this thing works. So you want to put your object, if it fits in the tray, that's even better. And you want to put your masses so they are inside of here, because although this is a nice balance scale, it's not that sophisticated, and you can run into some problems, some instrument errors or human errors by how you put this. So go ahead and practice on your balance scale using these known, each one of these is 1 gram, while the rest of your teammate is preparing your bags. All right, so we're applying some science skills. We're applying science methods. Since we're going to apply science methods, we want to start with a question, a hypothesis, and identify some variables. I think you know a little bit more about it because now you have prepared your 3 bags and you've looked at some of the instruments and the temperature that you have in your room. So let's apply this here. We have, what's the best way to slow down the rate at which ice melts? So our question is, which insulator is better at slowing the rate at which ice melts? We have 3 insulators, wool, newspaper, or just unwrapped plastic. All right, the next thing I want to do is let's take a look at the 3 hypotheses. I want you to write a hypothesis by circling one choice and finishing the sentence. If bags containing identical ice cubes are wrapped in wool cloth or wrapped in newspaper or unwrapped, then the ice cube, now you pick your hypothesis. I don't care which one. Wool, newspaper, unwrapped will take the longest to melt. Now, I might have a crazy idea that wool is what sheep wear, keeps them warm. Newspaper has lots of layers, or maybe unwrapped, the light helps it stay frozen. So I don't know. What if I pick? I'm going to pick. It doesn't matter. It's what you think. You choose, and you have to give a reason. So I'm going to pick number C, unwrapped. I think unwrapped, it will take the longest to melt because the light slows down melting. That's what I think. I'm going to try to use science methods to prove it. So you select A, B, or C and give us a reason to complete your hypothesis. So we've got a question, a hypothesis. Let's look about some of the variables. That means some of the things that could mess up our experiment or things that we have to control to make sure they're the same. Let's take a look at In this experiment, you will measure the time it takes for ice cubes to melt. We're going to measure not only time, we're going to measure mass. You will change only one variable. Everything else must remain the same. What should stay the same? Okay, I need two examples. All right, so we think that the room temperature is going to stay the same, the bag size and the ice cubes are going to stay the same. The one thing we're going to change is we're going to change the insulators. So one bag is going to be wool, one's going to be newsprint or newspaper, and one's just going to be plastic. So these things are changed. These things are not. Before we can start our investigation, we need to make sure that we know the steps we're going to take. So I would like you to write these steps. Teachers, if you'd write these steps on the board, and boys and girls, you write them in your workbook on page 163. I want you to list the steps right here. So the steps for this ice investigation. Number one, we're going to prepare bags A and B, which is the wool and newspaper. And you've already done that. Check. Step two, I'm going to add one ice cube to each bag. We haven't done that yet. I'll get the ice in just a minute. Step three, which you've already done, you're going to record the room temperature in degrees Fahrenheit. And you've already done that. Step four, you're going to use a balance scale to measure and record the mass of each bag in grams. You're going to use a balance scale to measure and record the mass of each bag in grams. Step five, you're going to wait 10 minutes. And this is very important. Step six, you're going to pour off melted water. And then step seven, you're going to repeat steps 4, 5, and 6 4 times. So I'm going to put this up because these will repeat each time. And let me give you a chance to copy this down. Let's take just a few seconds to prepare our data sheet. And that is on page 164 in your workbook. And it looks like this. We're going to do the test in just a second, but let's look at number 9. And I'm going to change this a little bit. So get your pencil ready, and I want you to do this with me, okay? And here's how it looks. Ready? Take your pencil and draw this line up right here. Okay? Now we're going to divide this into 3 sections. So I'm going to draw a line right here and a line right here. So now there's 3 sections here. I'm going to do the same thing here. I'm going to divide this into 3 sections. Ready? Okay, now I have 6 columns. I'm going to put an X across this column. I don't need it. Not on this line, but on this line I'm going to make it a little bit darker. Okay? This is going to say start. This is going to say plus 10 minutes. This is going to say plus 20 minutes. It's going to say plus 30 minutes. It's going to say plus 40 minutes. All right? So I have start, plus 10, plus 20, plus 30, plus 40. Write the word bag here. Bag A. Bag B. Bag C. Those are our 3 bags. And I want to start this experiment right now, so it is 1:10. We'll do it again at 1:20, 1:30, 1:40, and be finished at 2 o'clock. And since we're going to measure in grams, I'm going to put a G by all of these and leave room to put my numbers in. It's important to put our labels, and our labels are in grams. Go ahead and get your data sheet to look just like this. Okay, each group is now going to get 3 ice cubes. And let me get my ice cubes out here. And I got my 3 ice cubes. And these are together. I want to make sure they're the same size. And I want to put 1 in each bag. Bag A. Bag B. And bag C. Seal it. And now my procedures say that I need to find the mass of each one. So that's what I'm going to do. I'm going to lay my bag on my balance scale, and I'm going to put my masses here, and I'm going to make sure I lay it on there every time the same way. There's 2 ways you can put these on here till it's even and then count them, or you can do it till they're even. I think I'm going to put mine on there till that's too much. I'm going to take 1 away. Still there, that's about right, maybe 1 more away. I'm going to find the mass of each one of my bags with the ice cube, and I've already started the clock, so go ahead and do that and record that on your data sheet. All right, so I made my first measurement of my bags and my ice cube. As you can see from my data, at the start, bag A, the wool was 25 grams, B, newspaper 25 grams, and C, 20 grams. And I'm going to wait 10 minutes, and I'm going to pour the water off. And when I pour the water off, then I'm going to remeasure it. And so if you take a look at this, it's almost been 10 minutes, and you can see, maybe you can see right here that there is some ice still and some water. So I'm going to pour off that water right there. Keep the ice, I'm going to keep the ice cube in the bag. If I can open up the bag, that is. Here we go. I'm going to hold the ice cube and I'm going to pour off some water. That's mass that is melted, and then I'm losing. I'm going to shake it a little bit, seal it, do that to all 3 bags, and then follow your steps, measure them again. And when I do that, here's what I got. 25 grams still for A, 25 grams still for, because no water came out of those bags, and I got 18 grams for bag C. That's my data. Your data may be different. Go ahead and do your second step. It's important that we make a graph of it, and this is something that you might want to just set up right now. Okay, so this is going to be our graph sheet right here. We need a title, and it's called Slow Ice Melt. And put the date on it. Now you can set this up different ways, but I'm going to set this up over here, the mass in grams on this side, and the bags on down here at the bottom. Okay? So we have slow ice melt, the mass on this side in grams, and the bags. Now I'm going to use these ticks. That's going to be 0, 10 grams, 20 grams. See how I'm skipping every other one? 30 grams. And I know that mine's 25, so I don't need to go much higher than that. But you see how I skipped one. Bag A, wool. Bag B, newspaper. And bag C, unwrapped. Okay? So we're going to set this up as a bar graph. That's what it says here, is a bar graph, just like that. But right now it's time for me to take my third reading. Enough to start it. So I'm going to end up having 4 different data points for each bag. Up here, I know that the wool bag, bag A, started at 25. So I'm going to put me a bar graph. Up here is 20, 25. So it started at 25 grams. And I think I might just zoom in so you can see this just a little bit better. Okay? So it started at 25 grams. Bag B, the newspaper, started at 25 grams. And bag C, unwrapped, started at 20. So 20 only goes up to here. Now I could actually write the numbers up here. I could write 20, 5, 25, and 20. Or I could put above it. But I'd like to do this. Since this is my first one, I'm going to go ahead and color this one in, because that's the fun of a bar graph. I'm going to color this in yellow. You have some colored markers. That'd be cool to do. So that was my very first one. My second one, and I can make a little key over here if I want. Now this is, see, that's this one right up here. So at 110, when I started, that's that one right there. See how they match down here? And I think I'll make a little box here to show what that stands for. And that stands for start. See how I'm doing this? So I know that's start. My second one, which is up here, my second one, which was at 120. So that's after 10 minutes. Plus 10 minutes. And let me see what that was. Okay, I was 25. Still. And I was 25. Still. And this one was actually 18. So this one dropped down a little bit. The unwrapped dropped down a little bit, 18. So you see, some of them stayed the same. And if you have colored markers or crayons, that's the perfect use of these for something like a bar graph to help scientists see their data easily and separately. Okay, and my third data point, which I've done up here, I think I'll use the green for that. I have a green marker, so it's going to be green. So this was after 20 minutes, which would look like this. Plus 20 minutes. And let me read what it is. 23. 22. And 15. So I can go back and actually write these numbers in. 23, 22, and 15. And we're starting to see a little bit of a trend, something weird going on. These are starting to lose a little bit. And this one has lost the most. It has lost 5 grams so far. And look at my watch. It's now time for me to take one more reading here. It's time for me to take a reading for 40 minutes, or actually 30 minutes at 1:40. So I'm going to do that now. Okay, I've taken my last reading, and I think I'm going to use my second to my last reading. I'm going to use purple for this one. And I'm going to make my purple key after 30 minutes. And I'm going to record my different gram amounts right here. This one stayed at 23. This one went to 20. And this one's gone to 12. Wow, looks like the unwrapped is not staying melted. The different colors just help me see the times a little bit better. And I have one more time to do. $20, $15, and $5. So that is a big difference. And so what I would like to do is take a look at this from, I started at 25. So on this one, I started at 25 grams. I ended at 20. So I had a loss of 5 grams. This one, I started at 25. I ended at 15. This one, I had a loss of 10 grams. This one I started at 20, okay? I ended up at 5. I had a loss of 15 grams. And so by looking at this data, I can see that which one lost the most. This one lost the most. The one that slowed down would be this one right here, only 5 grams. So who slowed down the most? A, the wool. And so what I need to do is go back and take a look at my hypothesis and at my conclusion and finish the workbook to realize that my data does not support my hypothesis, but yours might. And so go ahead and finish your investigation, collect your data, analyze it, and come to your conclusion. But you know the thing I like best about this entire project is if you look right here on the top of page 164, it says, we followed the steps, we recorded our results, and this is something that you might try tomorrow, teachers. Scientists repeat their test to improve their accuracy. Repeat the test if time allows. So maybe tomorrow you can set this up again. You already have your balance scales, you already have your bags. All you need to do is get some ice, keep the variables the same, and see if you can add more data to support your hypothesis. Hey, this has been a great investigation. We've been applying scientific methods to heat insulation and heat conduction. I'll see you next time.